Hey guys, we're just gonna give everybody like 5 more minutes to join. And when they join, we're gonna continue with question six, the drilling. So we're gonna start in 5 minutes, okay? All right, guys, let's get started. Okay, so everything we did earlier today, it should assist us in getting through these questions a lot faster. If you could hear me say yes, so that I could know to just jump right into it. Okay. All right, so let's continue. We are here at June 2022. Hello? Yeah, I was talking and I don't know how come my computer glitching a little bit. So y'all can hear me now? Oh my God, I gotta start over. Okay, so let me start over because I was talking this whole entire time. So as I was saying, let's read this entire thing and then analyze to make sure we understand what we're looking at. Because remember, based on the previous examples we did earlier, it's important to understand the diagram and how the information they give us is represented. So again, it says the diagram below shows a solid made from a semicircular cylindrical base. Okay, that's this part here, with a rectangular prism above it. So before, like these other examples, I think I skip a year. Yeah, we're into 23. Okay, so I'll do 23 and go back to 22. That's okay. That's okay. So like I was saying, you see how these two had two shapes and they were related to each other? The difference is they put two shapes in one. So we see here that there is the rectangular prism above, and we understand how a rectangular prism works, right? Based on the formulas and everything we know about it. And then the base is the semicircular cylindrical base, just like what we saw in the notes and the formulas. It says the diameter of the cylindrical base and the width of the rectangular prism are 4 centimeters each. So let's make sure we understand the diagram. So based on this information, anybody could tell me what shape this is in the face of the prism? What shape is this? With the hand kind of going circular on the on the right hand side. It's a square. You got to pay attention. It's a square. How I know it's a square? The height is 4 and the width is 4. Everybody see what I'm showing you? You gotta make sure you understand that. Then the front and the back, the top and the bottom, those are the rectangles. Okay, so make sure you understand that. This, even though this does not look like a semicircle, it is a semicircle. So we know that if they were to break this up, we will get a rectangle and 2 semicircles on the side. All right, calculate the total surface area of the solid. Everybody see what's going on now? You see why it's important to understand the different size of the shape? The surface area of a cylindrical radius R is A equal 2 pi R squared plus 2 pi RH. Now, what do we realize about this? Is the base an entire cylinder or it's a semicircle cylinder? So first of all, before you start, we need to figure out how much sides we got in all. Everybody agree? So let's bust up these two shapes in two. because we know the top part. So I'm just going to break up the top part using this line. So everybody see the top part? And I have a question for you. How many things you think we're going to be adding? This is a very serious question. How many sides, just like what we talked about before when we were looking at the trapezium prism? Everybody watch this and tell me how much faces we got to add together to find the total surface area. Just make a look at it, count, and tell me how much you get. And then I will do it and tell you. Total surface area means every face, we got to find the area of that face and then add it up. So, okay, one person said 6. Another person says 6. One person says 7. Come on, everybody, take a try, please. Somebody else said 8. Another person said 8. Because before you start calculating, you got to know what you're calculating. You got to make sure you understand what all sides you need. All right, so I'm going to give it a go. So first of all, I'm going to separate the two. I'm going to look at the prism first, and then I'm going to look at the cylindrical base at the bottom. Remember, it says total surface area. So we're only looking at the faces that are on the outside of the shape. So I will count this, hold on there. I would start with the top part. So the top part has a left and a right. So that would be 1, that would be 2. Everybody agree? Then the back, which I will count as 3, the top, which is 4, the front, which is 5. Everybody realize what I mean counting the bottom, right? Everybody understand why I'm not counting the bottom. I can't count the bottom because the bottom is not exposed at the surface. It is inside. So it's not counted. Everybody with me? I want to stop here before I continue. Make sure you understand. Remember, the surface is like, this is one big shape. Even though 2 shapes are put together, it's one shape and you can't see inside. So far we got the top half, the left and the right, the top, the back, and the front. They're asking to calculate total surface area. Okay, how many faces does the bottom have? Let me see if you remember. That's an important question. How many surfaces does the bottom part have? Take a try. So one person said 2, one person said 5, one person said 4. Come on, guys. At the end of the day, you got to train yourself to answer these questions because how you gonna know what to do in the exam? So talk to me. How much faces you think it has? Guess what? It's only 3. How I get 3? Watch this now. 1, 2. Everybody agree? And 3. This side gone all wrong. This is one side. Because I remember what has happened when you open up a cylinder. When you open up a cylinder, doesn't it give us the rectangle? You remember? You see, everything I was doing before was for a reason. So in all, how much surfaces we got to add up together? If the top got 5 and the bottom got 3, in all, somebody actually did say it. Somebody said 8. It's 8 surfaces we got in all. Everybody with me? All right, so let's do the top part. The top part is easy. So let's start, oh my God, what is this? What's going on? So the top part is easy. Because for example, we know the left and the right. So it got 8 pieces. So let's start off with the left and the right. Left and right. The left and the right, it matching. Everybody agree? So what dimensions would that need? It would be 2 times what? What 2 dimensions we're going to use for the left and the right? Let me see if we're paying attention because this is the part I can't just tell you. Is a square. What 2 numbers we using for the left and the right sides, the outer boxes? 4 centimeters and 4 centimeters. Everybody agree? 4 times 4. So that's the left and the right. Let's do the top now. What numbers we using for the top? And I need everybody to try. Let's go. Because you got, even if you don't multiply, I need you to know that you're telling me what answers. Somebody said 12 times 12. Remember dimensions, you need a length and a width. You can't just tell me one. To find the area is length times width. So what two numbers are you using? Somebody said 12 and 4, 12 and 12. Anybody else? Answer is 12 and 4. Okay, what else we need for this? Front and back in it, because the front and the back would be the same. Agreed? So that would be front and back plus front and back. So that would be 2 times what? What numbers we need for the front and the back? 4 and what? Stop telling me 1 is 2 I need. So 4 and what? Look at the face for the front. What two numbers represent the front? 4 and 12. Everybody see the front? This is the front. So it'll be 4 and 12. All right, so that's the top part. Let's make sure we got 5. That's 2, that's 4, that's 5. If you got it, say got it. So that part easy. So is that plus the bottom? No, they gave us a formula for the bottom, right? They give you the formula for the surface area. Shouldn't I just use this and do one thing? What should I do with this formula then? Let me see who's focusing. Remember, the bottom of our shape is a semicircle, for a cylinder, and this is for the cylinder. So what should I do with this formula here? Excellent. Everybody agree? Hello? Okay, so you have 2 ways. You can literally say half and then substitute the formula. So the formula is what? 2 pi r square. I'm not calculating this. I'm just going through so you know how to answer it. 2 pi r square plus 2 pi rh. 2 pi rh. And we know what pi is. In this example, this is a serious question. What is r? What is r? I know that, okay, my bad. Let me re-ask the question. What's the value of r? Based on the information given, what's the value of r? What is the value of r? That means what number is r? Nope. That means I ain't reading. Nope. Y'all just looking and calling numbers. Nope. 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 Lucky, that's right. Nope. Read again. I can't. I'm not telling you the answer. I'm gonna just tell you, y'all not reading. It literally gave us a number in the caption that allows us to find r. Y'all cannot afford to just look and just call numbers. You go back and you read. So let's go. What is r? Eshban said 2. Is that true? Where he get 2 from? Where he get 2 from? Excellent. The diameter is 4. So if the diameter of, look, let's say here, the diameter of the cylindrical base is 4. Therefore, if we want the radius, we divide by 2. Everybody understand what I'm saying? Please note that this is why people get this question wrong. And that is why I'm making sure you find it by yourself, because you only gonna get you in the exam. All right. So we know R is 2. What would be H now? What would be H? Let me see if we remember the concept of H, because I explained that earlier today in class as well. What would be the value of H? So we know R is 2. That's true. R is 2. what would be the value of H? Excellent, excellent, excellent. Remember, height is, you look at where the base is, the top and the bottom, and how long the base runs is the height. And in this case, even though it's lying down, how long does it run? In 12. Everybody with me? Everybody understand why it's 12? Once it's a prism, you look for where the bases are, the top and the bottom bases, and however long that is your height, even though it's lying down. All right, so quick question. Would you be able to substitute these values and half it and find your answer? Yes or no? I'm watching the chat, so persons are answering directly to me. I'm waiting for everybody else. I asked if you were given, if I was to leave you to finish this question on your own by substituting and working it out and adding up everything, would you be able to do it? You substitute, you work out your answer, you break it down. All right, ladies and gentlemen, one of the most important things about question number 6 is understanding the diagram and the information given. To be honest, the question part, it could never come anything outside of volume, perimeter, surface area. Everybody see what's going on? Them is the basic things that gonna come, but it's not that, that's not the hard part. The hard part will always be making sure you understand the diagram and understanding what they're asking you from the diagram, okay? All right, so let's move on. Calculate the volume of the solid. Just like what we did before, all volumes have the same formula. Volume is equal to area of face, or the cross section, right? Times the height. Now, what about this is different? Wouldn't all of this be the face? We ain't got to put the two pieces together to get a face. And didn't we do that already? So we know the area of this would be what? 4 times 4 plus the area of this, which would be half of the area of a circle, which is pi r squared. And we know r is what? 2. So once you find out the area by adding these two things, we multiply it by the height. And what's the height? What's the number for the height again? 12. If you got it, say got it. I'm going to be honest with you. Question 6 should be the question, would be one of the questions you spend the longest time on, because it's going to take you a minute to kind of make sure you understand what's going on with your image. So that is why questions 1, 2, 4, even 3, you got to move as fast as possible to give yourself space for question number 6, even question number 5, because you know you always got to plot a graph. But based on what we did yesterday, is yesterday we had class? No, the last day we had class was Thursday. Yeah, based on what we did Thursday, you should be able to plot a graph like nothing. All right, so let's move on. So you know the height, and the height is 12. And you know the area of the face is a compound area where you got to find the area of two shapes and put them together. You're good to go. All right, next one. The solid is made from gold. 1 cubic centimeters. How do I write cubic centimeters? What cube mean? What power is cube again? Cubic. When you hear cubic, what's the power? Good. So that means 1 centimeters cube. You realize before I even continue, I'm making sure I write this information in a clearer way that I understand. Everybody see what I did there? Y'all realize the pattern on how I just answer questions? You know, you realize I don't go all the way to the end, then come back. As soon as I read it and I realize I know what this means, I write it. So it says 1 centimeter cubic of gold. So this would be gold, all right, gold underneath, has a mass of, so that's equal to 19.3 grams. Do you agree with the statement? So let me ask you a question. If you're going to change centimeters cube to grams, what are you going to do, multiply or divide? I taught this already as well. Everybody, multiply or divide? How we know multiply? Because we're moving from digit 1 to 19.3. If I'm moving from grams to centimeters cube, I'm going to do the opposite, which is what? Divide. Okay, I'm just making sure I also understand how to convert back and forth before I continue the question. The cost of 1 gram of gold is, and look, no, they give us another conversion. So they're saying now 1 gram of gold is equal to 42.62. Everybody realize this is 2 different conversions, one from centimeters cubed to grams, and then one from grams to money. All right, calculate the cost of gold used to make the solid. Anybody realize what's going on here now? Didn't we just calculate the volume of this, the shape, the volume of the shape? So what do you think you got to use? In the answer you got to use? No, we don't have a number. So let's just make up a number for now. Let's make up a number. Let's make up a number. Let's say 25. Let's say our answer is 25. And everybody know why it's going to be 25 centimeters cube, right? Because the dimensions we were given was in centimeters, right? So let's say our answer was 25 centimeters cube. So 25 centimeters cube is the solid. Everybody with me so long? How do I calculate the cost of that? Mega first find out how much grams this is, and then from the grams find out the cost. So tell me what I should do now. How do I change centimeters cubed to grams? Multiply. Excellent. By what number? Somebody I talk. Is she correct? No, Elena, I don't know, right? If y'all don't respond, I don't, because I tired and I hear with I and I not answering. So let me know what I want to do. So it's either we responding and we participating, or I'm going to lay down and watch Netflix. So I'm going to ask one more time. Do you agree with what she said? Is either yes or no? She's correct. No, let me ask you a question. When I write it out like this, didn't it make it easier to see what we need to do? Main care about the calculation part. The calculation part is easy. The part that is hard is understanding how you know what to do with the information you're given. So this is the trick, everybody. If they tell you something is equal to something or something is something, you write it out just like that. They tell you something else is equal to something. And then when you do that, you're going to realize, oh, okay, this is to change centimeters cubed to grams, because this is the conversion rate, just like money. If they say US into Barbados dollars and then Barbados into Trinidad dollars, it's just like that. Then they tell you grams to money. But you're like, oh, okay. So for me to get from centimeters cube to money, I got to change first the centimeters cube to grams, and then from the grams into the money. If you got it, say got it. So exactly what we're supposed to do first is take this, multiply it by 19.3, and that answer gonna be in grams. And then what we're gonna do after we turn it into grams, we're gonna multiply or divide. That's why I ask. We're gonna multiply or divide. Everybody come, tell me, choose one. It's only one or the other. We know we don't multiply, we answer in grams. What we gonna do, multiply or divide? That means y'all ain't understand. Watch the numbers. We're going from 1 to 42. There's no way I could divide and get 1 and increase the number, the digits. Everybody understand? Remember, that's how you're supposed to do it, Look at what happened into the digits. 1 gone to 42. So to go from grams to money is an increase, which means a multiply. From money back to grams would be a divide. Everybody see that? Let's make sure we understand how to convert things. We can't make that mistake again. So after you multiply by 19.3, that answer, you multiply by 4262. Next one is to calculate the volume of the solid. Oh, these questions repeated. Oh, ma'am. Yeah, this was the whole question. I realized I copied the question twice. Everybody, you know that was a whole exam, a whole question number 6? Yeah, I realized that was a whole question number 6 we just do there. Why would you divide? You don't turn it into grams. 1 gram is 4260. So you got to just multiply it by 4260 to find out. For every 1 gram, you pay 4260. So if you got 12 grams, it ain't gonna be 12 times this. You got it? But everybody see how short and sweet this question was? But why would it have been hard? Let's discuss that. What would have make it hard? You would have been confused about the 2 pieces in it. All right, let's go back to the exam before. Let's bust through this quick. January 2023. All right, so here we see another compound, a composite shape, because here is a semicircle and here is a semicircle. So in essence, we got 2 shapes. Everybody realize the 2 shapes we got? A rectangle and a whole circle. Agreed? Not because they're separated. Both of them put together creates a whole circle. All right, so it says use 20. You realize they're always telling us must use 22/7 as pi, but that's okay. The diagram below shows a scale drawing of a running track. It consists of a rectangle and 2 semicircles with diameters LN, MP, and all of that equals 49 meters, and LMP and whatever. Show that the total length of the running track is 350 meters. When they say show, that ain't mean this is the answer. So all we got to do is add up everything and prove and make sure the answer add up to 350. Everybody with me? How many sides we gonna add? How many things we gonna add to find the total length? The total length would be the perimeter. How much things do you think we adding up? And I want you to think about it. Okay, so I got 1 person saying 4, 2 persons saying 4, everybody saying 4. The answer is 3. You got this side, which can also be 98 meters. Everybody with me? That's 1. This side is 98 meters, which is 2. When I find the circumference of a circle, isn't that 1 calculation? Because I just gotta find the circumference of the 1 circle. Hello? If you got it, say got it. You see why I tell her about paying attention to details? You don't ever just jump into the question. You look at what you got going on. Not because these 2 circles, the semicircle separated. When I calculate, it's gonna be 1 circle. So it's 1 calculation. So that 1 calculation gonna give me 1 answer, which is the circumference for the entire circle, which represents both halves. And then I add the 2 sides. So there we go. So that gonna be what's the formula for the circumference of a circle? This is given in the formula sheet, even though, again, I would prefer if you know these formulas out your head. I didn't copy over the formula sheet. You got? I did. But anyways, that's okay. We should know the formula out we heads, to be honest with you. Somebody said it just now, 2 pi r. So it's the circumference of circle plus 98 plus 98. So that would be what? 2 pi r plus 98 plus 98. What would be r? What will be r, everybody? What's the value of r? I can't believe I just do that. Look at the diagram and tell me what is r. R is the radius. What is the value of r? I can't believe I gonna watch this and tell me the r is 49. What does this mean? Go back to the thing again. 49 in the diameter. Attention to detail is what gonna make all you struggle in this exam. Not because y'all ain't knowing. Attention to details. Remember, I tell you so. You got to go in with your eyes wide open, like you're hunting for like all the tricks and all the things to confuse you. You never watch a number and assume that's what you need. This is 49 is the diameter. I'm asking for the radius, which means that I should divide 49 by 2. All I'm looking for is better accuracy and focus, okay? So that means we got to use 2 times 22 over 7 times 40, 29, 24.5. So once you find that, you add it to 98 plus 98 and you're good to go. If you got it, say got it. This question is going to be made to test your reading comprehension. And let me explain something to you. The CXC pass is based on profiles. One of the profiles is reading comprehension. I know a student who got an A, a B, a C, and an E in comprehension and failed with a 4. Yeah, understand what I'm trying to show you? You realize that's where you're focusing on making sure you understand how to read, because you could do good at all kind of things, but if you can't read, you could still fail the exam. So you have to pay attention to the details. All right, let's keep moving. The next part says Nathan walks at a constant rate of 1.4 miles per second, meters per second. Anybody could tell me what the formula is for rate? I did this question already in a class. Anytime you see rate come up with this is the formula. This tells you what the formula is. What M over S mean? What over mean? What does dash mean? What operation does that represent? Division. Didn't I give out the formula earlier today? So rate, the rate that he's walking, which is actually the speed, is meters over seconds. Everybody realizes meters over seconds? Which is essentially what? Distance over time, which is the formula I gave out earlier. Everybody with me? So to calculate the rate, you divide the meters by the seconds. Okay. It says calculate the time it will take him to walk 7 laps around the track. No. First of all, does telling us 7 laps tell us anything? 7 laps tell us he gone around 7 times. That doesn't mean we need to know how long 1 lap is. So 1 lap, do we know this information? Let me see who thinking. Do we know how much is 1 lap? That ain't what we just calculate before. Didn't we calculate the distance around the whole track? That's the distance around 1 lap. So let's say that ends up giving us 300 meters, 350 meters. Oh, my estimation wasn't that bad. Thank you. So we know 1 lap is 350 meters. Based on the formula, what they ask us for. So we got rate is equal to meters over time, seconds. Distance over time. Out of these 3, which 2 we got? The rate don't change. Everybody realize that? The rate don't change. So we ain't got the rate. What's the rate? 1.4. What do we have? Don't we have D? These were 350. What do we need? A and T. Who could tell me what we're supposed to do from here now? This ain't algebra. So now my question is, do we switch or do I multiply? Excellent job, everybody. We switch. Anytime the thing that you want is in the denominator, you switch these two things. So T is equal to 350 divided by 1.4. So tell me what the answer is, please. 250? 250 what? Let me see who thinking. 250 what? Wrong. I too rush to answer. I just tell you, we just calculate time. How could you tell me time is meters? Seconds, right or wrong? Then what we say in the top in the beginning, meters per second. I'm gonna fight, you know. I jump to I feel like if I wish I could be in the exam peeping over our shoulder. If I see something like this, I just get a scuff in the exam, be like, what are you doing? So the answer is 250 seconds. I have a random request. Turn that into minutes. Lord help us. How much is 250 minutes? I know what to do. How do you change seconds into minutes? Anybody? Somebody? How do we change? Oh, boy, no. If you, let me tell you something. You see this multiply divide thing, it gonna mash eye up. This is what to do in the exam. If you're not sure, you write this out. You know, 1 minute is equal to 60 seconds. Look at where you're moving from. You're moving from seconds to minutes. So 60 to 1. What I tell you, you got to do. What I tell you, you got to do. Divide. Everybody see that? All right. So the answer is going to be essentially 4 minutes because you're rounding it off. All right, let's go. Last one. But everybody understand how I did that? If you got it, you got it. You use this here to find the formula. Let me just repeat it again. This is the formula. M over S means rate is equal to meters divided by seconds. Another thing that they could give you, they could say meters per second. If they give you meters per second, per means to divide as well. Okay? All right. Moving on. Tafari runs 1 lap of track in 68 seconds. Determine the number of laps Tafari can complete in 1 hour, running at the same speed. Tafari runs 1 lap of the track in 60 seconds, right? So remember, rate is distance over time. Everybody agree? No, he's running at a different speed, you know, so we gotta calculate that. If he run 1 lap, what I mean, we don't know the distance for 1 lap. What is the distance of 1 lap again? 350 over, and we're gonna put 350 over in the seconds. So meters over seconds, which is what? 68. So tell me the speed he running at. Because this is a new speed, a new rate. Calculator people. So now our new rate is 5.15 meters per second. Yeah? So from this, it says determine the number of laps he can complete in 1 hour running at the same speed. So which means one number not going to change. One number not going to change. in the 5.15. If that's the speed he was going before and ain't changing. So what we gonna do? We're gonna start off with the formula again. The formula always stay the same. So rate is equal to distance over time. So one number don't change, this number ain't changing, so that's 5.15 equal, what information they give us now? They want to know the number of laps, so that means they want to find the distance. So we're gonna put that as X. Everybody with me? Over wait. Hold on, guys, hold on. All right, guys. So as I was saying, what information now we have? We don't have the time. We got the time? What was the time? What's the new time? I'm not saying it, so somebody got to say it. In the same sentence, when they asked us to find the number of laps, they gave us two pieces of information, that the speed remained the same and they gave us a time. What was the time they gave us? That's not true. That means y'all still not reading. Look at the question. Look at the time. Tell me if anybody see it. As we do them, you know, we do them. Everybody see the 1 hour? Question, do I write 1 hour here? Let's see if we really focusing. Do I write 1 hour here? Can I use hours? No, because what type of time unit we must use? We must use seconds. So that means we got to change 1 hour into seconds. And before me and I fight, nobody tell me 60 seconds, because we all know 1 hour could never be 60 seconds. So tell me what number of seconds is in an hour? So again, stop the impulsive reactive answering. That's a guess or that's a calculation. Thank you. Thank you. Anybody else trying? So some people saying 1440, some people saying 3600. Come on, let's go. If you can't, tell me how to change our hour, 1 hour into seconds. We got a problem. We got a problem. Houston, we got a problem. First of all, I need to change 1 hour to minutes and then minutes into seconds. 1 hour is 60 minutes and then minutes is 60 seconds. So that means I gotta say 1 times 60, 60, so that's 60 minutes. And then change minutes into seconds. I time that by 60 again. 6 times 6 is 36 and 2 zeros, 3600. Everybody with me? So at least everybody was able to realize that we couldn't just use 1 hour. We had to change it into seconds. So there's going to be 3600. And please know they're going to always do that because they expect you to know how to convert one unit of measurement into another. If you ain't noticed, it's going to be centimeters cubed to liters, or one time unit into another, or distance into another. So what do I do from here now? Do I multiply or do I switch? Excellent. Because we want to get rid of divided by 3600, we multiply by 360. Whatever we do on one side, we do on the other side. And so X, which would be, calculator peoples. Let me see if we focus in. Answer. How many meters he run? 18,540. Is this my final answer? Is this my final answer? No. They didn't ask for the distance. What they ask us for, how much laps? What do I do to find out how much laps? One lap is how much? 350. What do you think I got to do with that? Excellent. So number of laps is this number divided by 350. Do that quick. $53 laps. 53 laps? 50 flat as in no decimal? Exact? Oh yes. Hey, who teach I by? Who teach I by? A smart bar rounding off without nobody telling you. Okay. 53 laps. I like it. Excellent work. Excellent work. Excellent work. Love to see it. But talk to me. Everybody understand what we did there? I find one year the question short, another year the question long. Because ask me why they got another question. They ain't tired of stressing people out. Why we got next piece? Why is there another piece to this question? What else they could want? Okay, let's go. Nathan completes running one lap of the track. Nathan completes running one lap of the track every 72 seconds. So one lap every 72 seconds. And one lap equals or gives us, yeah. Tafari and Nathan start running at the same time from point L on the track. Each completed a number of laps of the track. Calculate the least number of laps that each person will complete before they're both at point L, again at the same time. All I want is if you understand this question. That's all I want. You understand it and be honest with me, yes or no. I get in some no's. I get one yeah, a little. Talk to me, people. Be honest with me if you understand what it's asking for. And similar to probability, actually similar to LCM. Anytime, right? Somebody asks to find the least number of laps each person can both complete at the same time. Everybody understand what I'm saying? What is the LCM? The lowest common multiple. What year this was? January 23. Hold on there. January 2023. Everybody see so that's why I came here to show you. Everybody see my screen? Why I should tell you about the LCM? I was just too tired to go write out all of this, to be honest with you. I just wanted to show you what this is showing you. Tafari takes 72 seconds for one lap. Nathan takes 68 seconds to run a lap. So what it did is find the LCM of 72 and 68, which was this number here. And they take the same number, and because both of them run at different speeds, they take the same number and then divide it by 72 and see how much laps they could have get out of it. Everybody see what's going on? So they find the common time, because this was the common time that both of them could run and end up at the same place at the same time. And then remember, both of them still running different times. So they're gonna take the same common multiple and see how much laps each person could have get from that common time. Everybody with me? Listen to me. If you ever reach a question like this and you can't figure it out, it's okay to just leave it. Okay, just leave it. Don't stress yourself. All right, that's all I wanted to show you guys from this. Remember, this is the FastPass exams. So if you ever want to do some past papers by yourself, you could use the FastPass website that I sent you guys and go to the solution papers, because you realize they got all the explanations and they have all of the working. All right, so let's move on to another year. Oh my God. When now I see certain question, you just take a deep breath and I feel like when I saw this, I was like, this would be the last thing I would recommend. Question 6 should be the last question that you do. Yeah, I hear what I tell you. Question 6 gonna mentally like drain you. I'm gonna be honest. Question 6 gonna take the most thinking than all the other questions. So my recommendation is for you to do the exam in this order. Do number 1, do number 2, skip 3. You could do 3 if you're good with 3, because remember 3 is like reflection, rotation, and I think we did a good job with number 3 and the different angles. So I would say try number 3. Do as much as you can, even if it's half. Do number 4, number 5, skip number 6, do number 7, skip number 8, do number 9, do number 10, then go back to question number 6, number 8, do 8 first, then number 6 last. Why all these crying faces? What's going on? This ain't make sense. Let me talk about it. Doesn't this strategy make sense? If you do number 6 in the middle of your time, you know what I'm going to do to you for the rest of the exam? You're going to mentally frustrate yourself and be exhausted. So when it comes to things that you would naturally do good in, because that question stress you out, it gonna put you in a bad space where you can't even like move in more confidence. Everybody see what I'm saying? And honestly, maybe I should have leave question 6 last, because this is a lot, but still, I'm still happy that we're doing it now. So all I need to know is if you agree or you think there's a better strategy, because you should be going into the exam with one. You should be going into the exam knowing which questions is your strongest questions. Just a heads up, guys, my current is dipping. I don't know why. Like it dipped just now. So if y'all see me log out, it because current gone, because I don't know what's going on. The lights keep dimming and coming back up. Anybody else had current issues today? West side, Skellig has issues right now. They acting up for you. All right. I don't know if they're changing anything. I don't know neither because it just keep happening and I feel like it gonna mash up my AC. All right, so let's get back here. Let's get back here. This only looks so maybe ain't as hard, right? We could do this. We could do this. Yeah, ready? Listen, I am a realistic teacher, you know. I'm not gonna pretend to y'all that these things ain't exhausting because I am gonna be honest with you, I am exhausted. Which is why it's important to start mentally preparing yourself from now. Yeah, a question like this, I personally, if I was a student, maybe I just skip, maybe even reading this. I gotta just skip this and come back last. All right, there we go. Oof. You know what? I'm gonna use the past paper exam because I tired. It is a water thing. It is like a water fountain. All right, it says here, a track meet, a signaling, a track, at a track meet, sorry, at a track meet, a cylindrical container fitted with a pipe, as shown in the diagram below, is used to serve water to athletes. The cylindrical container of radius 12 centimeters, and it's in the diagram already, so we don't have to write it in, and height 20 centimeters, okay? So in my mind, I done started to take volume, eh? Everybody with me? You should be thinking volume. We got everything we need to find the volume of this tank. Is in centimeters is completely filled with water. So that means when we find the volume, we find all the water in the tank. And the pipe fitted to the bottom dispenses water into a cone-shaped cup. The cone-shaped cup has a radius of 3 centimeters and a height of 8 centimeters. And if we remember to find the volume of a cone, you need the height and the radius. Everybody with me? So in my mind, this question seems pretty straight up, right? Everybody else still here? I know y'all tired. This is gonna be the last one. So just let me know you're still alive. Are you here with me? Holding on for dear life. But we only got one more week to go. We gotta hold on. Yeah, I feel nervous. So if I feel nervous, I know. I know. But all I'm gonna tell you, just listen to my voice in the exam. No punk vibes. Do not punk. Anytime you see yourself starting to panic, just pretend you hear my voice in the back of your head saying, stop your shit. No punk vibes. Focus. Focus. You better stop talking about your one cray. Stop it. No punk vibes. Fight to the end. Till the end. You fight. If you gotta make up a formula, make up a formula. Do not give up. Let's go. All right, so the first question is calculate the volume. Look how easy the first question is. Calculate the volume of the cylindrical thing. So we know from jump, V equals A times H, and A of this thing, which is pi r square. So that's an easy fix. Whap, whap, whap. Just like that, we got the answer for that. Just like that, easy maths. Even if you get the first 2 marks, it's better than nothing. Whew. All right. Pi r square H, very good, times that, whap, 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 whap. But what they said they want the answer in, they said they want the answer in, I don't get excited, in liters. And you see, they give us, sometimes they don't do this, eh? You see how they give us the conversion rate? So question, how do you change centimeters cubed to liters? Multiply or divide? Let me see if anything is saying sticking. People, multiply or divide? Centimeters cubed to liters, because your answer gonna be centimeters cubed. How do I change centimeters cubed to liters? Look at what's going on with the digits. Look at what is happening to the digits. You're going from 1,000 to 1. What I mean? Correct. Divide. No. How you get multiply? Look at what's going on. You're decreasing. You're moving from 1,000 to 1. So from centimeters cubed to liters, it's going to be a divide. You see what I'm saying? Is it the same thing I was saying from before, or how to know when to multiply and when to divide? You check what I'm saying now? So you gotta be careful, okay? All right. So all we gotta do after we find the answer, you see here, you take your answer, you divide it by 1,000 to change it into liters. And then it says it wanted it to 2 decimal places. So you just round it off to 2 DPs, okay? And we should know how to round off to 2 DPs. If the number after is 5 or more, the number increases. Oh, not you, not you, not you. Remember, people is be responding to me directly. Water flows from the cylindrical container along the pipe into the cone shape at a rate of 7.8 milliliters per second. Anybody could tell me the formula for this? You realize we got another question with rate? So let's find out the formula for rate. Anybody could tell me the formula for rate? Take this sentence here and tell me the formula for the rate. So rate is equal to what? No, this is 2 different things. This is no longer distance. What does milliliter represent? When you got milliliters, what milliliters mean? I forgetting this is milliliters, you know. What does milliliters measure? For the time you hear liters, milliliters, centimeters cube, what quantity does that measure? Volume. Everybody see what's going on? Centimeters cube, meters cube, liters, ounces, all of that represent volume. So give me the formula now. It's going to be not distance over time, but volume over time. And what measurement the volume must come in? Milliliters divided by what? Per milliliter divided by seconds. If you got it, you got it. And one number don't change. Which number ain't gonna change? Excellent. The rate not gonna change. The 7.8 not gonna change. Everybody with me? Because that is what the consistency is. The only 2 things that could change is what? Either the volume or the time. So they say calculate the time taken given to fill the empty hold on there, see. Given to fill one of the empty cone-shaped cups. What information we need in the volume of the cone-shaped cup? They didn't give us that. Or we gotta calculate that. They gave us the volume of the cup? No. But they give us the information to find the volume of the cup. Agreed? Because we have the height and we have the radius. Everybody with me? So the first thing we gotta do is find the area of a cup. So you see, look at here, volume of the cone, which is the cup. And then now we got the volume, we substitute. So everybody see 7.8 is equal to, I don't like how they write this out. They just write this so horrible. So R is equal to volume over time. It's time they ask us for, right? So 7.8 is equal to the 75 milliliters over T. Anybody realize what I did? They switch, right? Everybody realize they switch? That's how 78 get on here. And then they round it off to the 10 seconds. If you got it, you got it. This ain't exactly like the example before. This is basically similar to what we did before. All right. So that there done. God help us again. Oh, we just got one more piece. We only got this question left. Okay, thank you, Jesus. Determine the number of empty cone-shaped cups that can be completely filled from the cylindrical. That easy. You take the number of water, you take the amount of water in the cone, in the big. Okay, this is what you do. You take the volume that we know for this and then you divide it by how much cups you could get. So we know the volume for this already. Call this V1, and we know the volume for this. So how much cups would be volume 1 divided by volume 2? Agreed? Okay, this wasn't so bad. You see, volume of the cylindrical container divided by volume of the cups. All right, how everybody feeling? I got serious migraine, so we're gonna end here today. So here's what you're gonna do for me. I suggest, listen to me, we got 1 week to go. Tomorrow we're doing question 7. Let me just fix our schedule now to make sure we're on track. Hold on there. So I need to just give y'all this information so y'all know what's going on, because we need to maximize this week. This is our last chance to prepare. So whatever weaknesses you guys have, we gotta try to fix them in this week. So we are a little behind schedule because we just finished 6, right? So Monday, which is tomorrow, I would like to do question 7 within 1 hour, and then 8 in the second hour. We ain't got to push. Tuesday, which is also online, we're going to question number 9. And don't forget, this one is patterns and sequences. This number is advanced algebra and functions and graphs. Number 9 is trigonometry, circle theorems. And number 10 is matrices and vectors. I have a question. Which one out of these 2 y'all think y'all need the most help? Question 9 or question 10? I know everybody's saying 9 there. I know everybody was gonna say 9. Everybody's saying 9. Wow. That means 9 need a day by itself. Okay. Wednesday is face-to-face at Washi for those students. If anybody want to come, you could come. But Wednesday is our last face-to-face. I have something special planned, so I need y'all to come to this class. It's very, very important. I need to see y'all face-to-face before the exam. Everybody understand? So I don't care what's going on. If the sun coming to the earth, if the earth crack open, if mermaids taking over the sea, make sure you're in class on Wednesday. Okay, and then Thursday, I don't think I could have class on Thursday because I have to work Thursday night, to be honest with you. But let me see what I'm doing Saturday. Remember, Sundays all day. Sundays all day. All day. What time we should start? 10 a.m. is okay? That give everybody some time to eat breakfast, hydrate, meditate, cry, get your panic going, get out your system. All right, so Sunday at 10 o'clock. Let me see. I want to do something on Saturday. If anybody want to join and need any extra help. But let me see what I got Saturday. Okay, I free Saturday afternoon. Saturday afternoon and night. So let's say from about 4 p.m. until, if anybody need me, you could get me. First come, first serve. So if somebody come to me first and say they got topics they want me to do and people want to join, I'll just send the link and you could join in if you want. Sounds good? Sunday, I am not going through past papers. Sunday, I'm going to make sure you know everything that you're supposed to know out your head. So I'm going to start from question 1, come right down to question 10, and make sure you know this formula, you know how to use it, you know when to use it. That's what we're going to be focusing on, because that's why in this week is to just make sure we learn the skills for the past papers. Sunday is mental preparation for the exam. Okay. I think that's okay. The only question that I might skip going back over, or I got to squeeze in somewhere, is number 10, because we can't do 10 on Wednesday again. So let's say Saturday is 10 then. Saturday is question number 10. All right. I know this look all over, but this is how I feel. Just so my mind feel. But I understand what's going on. All right, guys, how y'all thought about these sessions so far? Y'all feeling a little bit better? How y'all feeling 1 week before the exam? Is there anything that y'all want me to get for you to do? This is the time to tell me no, so I could get ready for this week. Should I do something else? Should I do something more? Should I, you could make your suggestions now, or if there's a topic too you want me to go back over again. Yeah, this is the time to tell me. Okay, the revision session's helping a lot. Okay, good. Circle theorems is what you're struggling on. Okay. So I should go back over everything with circle theorems when that class come up. Okay. Okay, let me write that down. Yeah, circle. What that means, guess what you gotta do? You gotta come class knowing them, you know. If you come class not knowing them, it's not gonna help. You got to spend some time memorizing them first. If you know them, it gonna make it so much easier. You understand what I'm saying? Somebody said question 6 again. Question 6 rough. I want to see if I could plug in an extra question 6 practice with you. Maybe over the weekend. Maybe Saturday. Do some more. Okay. Question 6, question 9. Everything else is okay though? Everything else feels manageable? I'm proud of you guys. I'm proud of you guys. Y'all looking like y'all making progress. And at the end of the day, you got to remember that it's you alone in the exam. The harder you work now, the better you're gonna feel in the exam. Trust me. So sacrifice doing all kind of distractions, put in the work, you could get it done in time for next week, Monday. All right. I believe in y'all. Proud of y'all. See y'all on Monday tomorrow night. Bye.